Okay, this will be the virtual office hours for Math 110 online. This is the first one that I'm doing, this actual math. The first and second day was all on logistics. So I will go to the Ask My Instructor page, and these are from the emails that I've sent, or emails that has been sent to me. This is the first one. This is review number 5.39. So this is number 39. Hold on a second. It is number 5. I'm sorry. It is number 25 online. So this is from the Intermediate Algebra Review, number 25 online. So in your Intermediate Algebra Review, this is number 25. So let's look at the question. It's asking basically to simplify this function because it's not an equation, it's a function. It is, I'm sorry, it's an expression. So what we'll do is there's all sorts of things you can do here. Now remember, you have the, let me make sure I have to turn the monitor so I can see it. The product rule is if you have two bases with different exponents and you are multiplying the two bases, you add the exponents. That is called the product rule. And then you have the quotient rule. And the quotient rule says that if you have two bases and you are dividing, then you subtract the exponents. And the power rule says that if you have an exponent raised to another exponent, you multiply the exponents. Now those all have to do with calculating and simplifying. There's two other rules that we use, and they are more of dealing with the negative exponents. One is called the inverse rule. And the inverse rule says that if you have x over x to the n over x to the m, and I'm sorry, I messed up. I was thinking of the inverse power rule. Let me fix that right quick. If I have a negative exponent, and I'm going to put negative exponent, x to the negative n over 1, and I can make that, I can flip it and make the exponent positive. I don't know what's wrong with this. Let's see if I got another. I'm putting dots all over the board. Let me see if I've got another one. Should have another one somewhere. Let me try this one. So, and if I have 1 over x to the negative n power, I can rewrite that as x to the n over 1. So I can flip the fraction and make the exponent positive. Okay? Now remember, these have to do with simplifying. Okay? Simplifying the expression. And then these two that I'm fixing to show you, this fourth one, the inverse rule, and the inverse power rule, is all about the negative exponent. Now, can you use these in any order? Yes, you will get the same answer. Okay? That's the question I get a lot. Can you do it all of it the same? Yes. Let me see if I can minimize this. I doubt it will let me. Nope, it's not going to let me. So I'm going to go over here and do the inverse power rule. Now the inverse power rule, again, is nothing but how to work with a negative exponent. So I've got a to the n over a to the m raised to the negative w power. If I flip what's on, I'm sorry, that should be y. Okay, a to the n, y to the m, whatever. If I flip what's on the inside, it will make that negative w positive. So y to the m over a to the n, and that is to the w power. Now, do you have to do that? No, you don't have to. These two rules right here, and I'm going to put these in yellow. These two rules right here are just if you want to make a negative exponent positive. You do not have to use these rules, okay? You can wait till the very end of the problem and see if you have a negative exponent and then do whatever you need to do to get rid of the negative exponent. But these are not essential. These just make the problem easier to work with a positive exponent. Okay, so pause the video and copy those down. Those are your five exponential rules. Okay, now I'm going to erase the board and we're going to do this problem. This problem says p to the negative 2 over q to the negative 4 raised to the negative 5th power. Now, at this point, there's nothing you can do to simplify this equation as far as the p and the q because they are different what? Bases. So the first three rules, the power rule, the first two rules, the product rule and the quotient rule, you can't use the law of exponents there because you have to have the same basis. So all we can rely on is the power rule and the inverse rule and the inverse power rule. I'm going to just go ahead and use the power rule here and here, and that will make the exponents positive. That's p to the 10th over q to the what? 20th. Because what's negative 5 times negative 2? Positive 10. What's negative 5 times negative 4? Positive 20. That's one way to do it. Now watch this. If I flip what's on the inside, q to the negative 4 over p to the negative, q to the negative 4th times p to the negative 2, I had brain bubble there for a minute, and raise it to the 5th power because that is now a positive exponent. I'm going to get q to the negative 20th over p to the negative 10, and we don't like exponents, so we use the inverse rule and flip it, and that gives us p to the 10th over q to the 20th. No matter how you do this problem, you're going to get the same what? You're going to get the same answer. So it doesn't matter how you do it, as long as you use the rules accordingly, you'll be okay. So your answer is p to the 10th over q to the 20th. Okay? I'm looking to see if there's another rule you can use. No, not really. Those are the only two rules you can use. Unless I'm just not looking. I'm trying to think about the problem, think about the next problem and all that. So there is the way that you can use that problem. Remember, the first three rules are actually simplification. The last two rules, the inverse rule and the inverse power rule, only have to deal with a negative exponent in the answer, and you don't have to worry about that till the end of the problem. Okay? So let's go to another question. Let me erase this. And we'll go to the second. Let's see what that one was. The second question. I'll get rid of this one. And let's go to the second question. And the second question, I'm going to delete that one. The second question is 1.2, number 1 in the book, and 1.2 homework question online, number 1. Okay, that should be this one. Okay, interval notation. Before we do interval notation, you've got to actually know the rules behind interval notation. And here they are. These two guys and these two guys. These two guys, when you use these two guys, you have to remember that you have on a number line, an open circle represents these two. And what else? Parentheses represent these two. And a dashed line, when you're talking about drawing a graph, an inequality graph, a dashed line represents these two signs. Now, down here, a closed circle on the number line represents these two because of the equals. Okay? And a set of brackets represents these two guys. And a solid line represents these two guys. So this is the rule you have to remember with interval notation. Now, let's say you do a problem and you come out with the following, that the x is between 0 and 2.9. Now, first of all, what kind of notation is this? This is set builder notation. And set builder notation basically is one way to write the answer. And that means x such that, let me erase that because that's kind of cramped up right there. And it's just a fancy way of writing the answer. X such that x is between 0 and 2.9. So you've got a solution set between 0 and 2.9. And you can write that, do it on a graph, on a number line. This is called negative infinity. This is called positive infinity. 0, 1, 2, 3, negative 1, negative 2, negative 3. So this is one of these guys. So we're going to use an open circle on 0. And I'm going to just erase the inside just so you can see it's open. I'm going to erase that inside there. And since this is erased on the inside, that's an open circle. And 2.9 is going to be right in there. So open circle goes at 2.9. And then take your highlighter and shade. Now, on a number line, this is between 0 and 2.9, but it is not inclusive. Okay, let's put that under here because that's what this means. Not inclusive means that you cannot use that number in the equation or the set. Okay, not inclusive. So this would be inclusive, which means by the equal sign, you can use the number in the solution set or the formula. So, how do you write this in interval notation? Easy. You read from left to right. We start at 0 and we end at 2.9. Do we touch 0? No. Open circle means parentheses. Do we touch 2.9? No. Open circle means parentheses. So that is your interval notation. Interval notation is used a good bit in algebra. In fact, I'd rather use interval notation than set builder notation. To me, set builder notation is just a lot of writing for nothing. Okay? So, two things you need to get from this question. This is set builder notation. Graphic to understand it. And then interval notation is another way to write set builder notation. Okay, that's that question. Pause it if you need to, because I'm fixing to erase it. So I'm going to erase it. And go to the next problem. Right. And I will delete that one. That's this one right here. And go to the next problem. The next problem is 1.2, number 23 in the book, number 9 online. And that's this one. Now, as you get into 1.2 and as you look at my videos, you should know that we're getting into the completing the square. Okay? Completing the square is what I use and what I drill my algebra students so that when they get to calculus, they won't have to worry about how to do it. Now, a quadratic equation or a quadratic form in general form is ax squared plus bx plus c is equal to 0. This is called a quadratic equation in standard form. You got a number here got a number here, you got a number here, and an example would be 2x squared plus 4x plus 6 is equal to 0. This forms a parabola. Now you should have looked at the video where I go through a parabolic function, family of graphs. That's a 2, so it's going to be a parabola. It could look anything like this, okay? Now I'm not going to get into the family of graphs here because that's in the video where I go through the family of graphs and then I go into completing the square. Now there's 3 parts to a parabola. There's the vertex, which is the lowest or highest point, depending on which way it's going. That's the vertex. The X-Intercept, where it crosses the what? The X-axis. And then the what? The Y-axis. The Y-Intercept. So you got 4 points that you want to find. Now, completing the square gives you all 4 points. And you don't have to depend on a calculator. You just have to depend on 6th grade math. But what happens is, when we get in high school, the teachers don't want to review that 6th grade math, so they force you to use a calculator, and you have to do the quadratic formula. The quadratic formula is only used when you have this. 2.1x squared plus 3.6x minus 2.1 is equal to 0. When you have decimal quadratics, that's when you use the quadratic formula, because there's no sense in killing yourself doing the decimal with completing the square. So when do you do this? It's very rare. So we're going to mark that out and not use the quadratic formula, because that's when you depend on the calculator. So we're going to depend on completing the square. First thing to do is make sure you write the problem in quadratic form. It is written in quadratic form right here. That is x squared plus 0x plus 5 minus 5. Sorry, I didn't see that. Okay, something's wrong with the... Okay, the right side is the only one that works. Left side don't work too good. Okay. Minus 5 is equal to 0. Now the reason we make the 0 here for the f of x, which is a fancy way of writing y, is remember your intercepts. When you want to find the x-intercepts, you plug in 0 for y. Y is equal to x squared minus 5. You plug in 0 for y and you solve. That's what we're doing. That's why I put the 0 in for the f of x. Now, the first step of completing the square is make sure this number is 1. And it is 1, so we can go on and complete the square. If it's not 1, you have to factor it out. And I'll show you that in the videos. All right, so x squared plus 0x plus blank is equal to 5 plus blank. I did 2 things there. I moved C. This is C. I move it over. There's only one place you can move it, on the other side. So I moved C over. It became a positive 5. And I added 2 blanks. Now, here is 80% of completing the square. B divided by 2 and square it. So make sure you write that down. And we're going to highlight that green, because that is super, super, super important that you remember that. Because if you don't do that little part right there, then you're not completing the square and you're going to get the problem wrong. So in this case, what is B? Well, B is right there. So 0 divided by 2, square it, and that's equal to 0. Now, it just so happens that this is probably the bottom of the barrel as far as being easy for the problem. And a lot of people say, well, I know how you solve that. You just bring 5 over and take the square root of 5. Yes, but you got to rely on the calculator to give you the square root of 5. I'm showing you how we're going to be doing it for the rest of the semester. Yes, it's nice to go over here and do it the easy way, but I'm trying to show you how to do completing the square, so that way, when you get to completing the square, you're not worried. But the easy way to do it is x squared minus 5 is equal to 0. X squared is equal to 5. Square root of x squared is equal to the square root of 5. And x is equal to what? 1.7 or, yeah, let's say 2.3 or something. I don't know. You got to put it in your calculator. Now, that's the way you can do it easily, and that might be what they want. But I'm going to show you, this is how I'm showing you the whole semester we're going to do completing the square all semester, so I'm not going to go back to the easy way and then show you the hard way and then bounce back and forth. I'm just going to show you how to do it the hard way all the time. Okay, so, and if you watch my videos, you're going to see I do completing the square on just about everything. So, I add 0 to both sides. Now, like I said, this is a problem that's on the bottom of the barrel, so it's not very difficult. When you do completing the square, and write this down because this is why I do completing the square, you're going to get shortcut number 1, which you need to watch the videos on your factoring review. Shortcut number 1 or shortcut number 2, which is dependent upon that sign. So that's going to give us x plus 0, quantity squared, is equal to 5. Now at this point, I'm going to take a highlighter, and I'm going to take a yellow highlighter, and I'm going to highlight this because at this point, you've got the vertex. That's your highest or lowest point. And you need to write this down, and it's also in the videos for last semester or the spring 110. Look up spring 2017 110. I go over this over and over and over. You can rewrite this in standard form. I'm going to rewrite it. I'm going to bring the 5 back over and I'm going to put f of x in front of it again. F of x is equal to x plus 0, quantity squared, minus 5. And this is what we call the standard intercept form. And you'll see the homework and the test asks for that. That's the basic, standard, whatever you want to call it, intercept form. Intercept form. Now, it doesn't do much good because you got to take the opposite, blah, blah, blah. Well, here I tell, when you want the vertex, you can do it 2 ways. Vertex is equal to the opposite of this and the opposite of this. Well, the opposite of 0 is 0, so you really can't do anything. So our vertex here is 0, negative 5. That's our vertex. If you get it down here, you take the opposite of this, which is 0, the opposite. So opposite and opposite. If it was a positive 2, you'd write it as negative 2. If it's negative 2, it's positive 2. And you see that in the horizontal shift videos where I show you the horizontal shift. You have to watch the videos, okay? So, and that's going to, you write the opposite of 0, which is 0, and then you just bring this down. And you get the same thing. Okay, bring down. I don't want you to think you take the opposite. You only take the opposite when it's in this form. You don't take the opposite down here. Okay, so that's our vertex, 0, negative 5. So 0, negative 5 is going to be, let's see, yeah, 0, negative 5 is going to be our vertex. And now we're going to keep on going. So I'm going to erase this over here. I'm going to keep on going and find our X-intercepts. How are you going to do that, Hubert? Well, you're just going to solve them. So I'm going to keep on going. X plus 0, quantity squared, is equal to 5. Take the square root of both sides. X plus 0 is equal to the square root of 5, which I think we said is 2.7. Heck, I don't know. Let's see. Square root of 4 is equal to 2. Square root of 9 is equal to 3. 2.5 is in the middle. 2.5 is right there. 4 to 9 is 5 half. That's 6.5 is equal to 2.5. So let's see, make sure. 4 to 9 is, 2.5. So half of 2.5 is 1.25. So that's going to be 5.25 right here is equal to 2.5. So I say it's around 2.37, somewhere around there. So I'm going to say positive or negative 2.37. 2.37. So X is equal to positive or negative 2.37. That's your X-intercepts. Now let's find the Y-intercept. Well, the Y-intercept is the easiest one. Take our handy dandy aqua color highlighter, and we're going to color. There's the Y-intercept right there. So, how do you graph this? Well, you just graph the top 4 points. Let's see, 2.37. You got to make this bigger, but 2.37 is right in there. Negative 2.37 is right in there. Our y-intercept is 0, negative 5. And our vertex is 0, negative 5, which is also the y-intercept. So it looks like that. Now, you can also find the domain and range. Domain and range with any number, x to the first, x to the second, x to the third, and so on. You're going to have all real numbers. The domain is all real numbers. Okay, because you can put any number in there. So the domain is all real numbers. The range is going to be dependent upon the parabola. The range is from negative 5 to infinity. Negative 5 to infinity. You can't touch infinity, so it gets 8. And you can touch negative 5, so that's your domain and range. Now, the reason I'm showing you all this right now is I'm showing you how to do the problem, but I'm also showing you where we're heading. Okay, chapters 1, 2, and 3 is all about this, completing the square. So I might as well show you. I did show you the easy way to do it. The 1.2 way to do it is take the square root of both sides in there. But I'm showing you where we're heading. And you might as well get it in 1.2 because you're going to see it in 1, 2, and 3. So go ahead and get used to it. That's how you do completing the square. Okay, so pause it and write it all down, rewind, do whatever you need to do to see what I did. If you need to send me another question, send me another one. That takes care of that question. Let me erase it. And the last question, if my board would work. My last question is 2.1, number 21. Remember, this is in the book. So if you go to 2.1 homework in the book, it looks like number 21. And this is number 5 on 2.1 homework. So that's number 5. So let's look and see what it looks like. Okay, this is domain and range. Now remember, those circles, remember me telling you? Everything revolves around those circles. What circles? The one I showed you a while ago. Let's write them down. You got these two, which is an open circle, parentheses, or the dashed line. And then you got these two, which can be a closed circle, and brackets, and a solid line. So you got to remember this. This goes with just about everything having to do with domain and range. So what is the function doing from left to right? It's basically decreasing, because we read from left to right, so you always start from the left. It's decreasing, then it levels out, then it's decreasing. So nowhere is this thing increasing. Left to right, it's decreasing, it mellows out, it levels out, and then so it's always decreasing. So that takes care of this question. It's never increasing, it's always decreasing. Okay? It's really not always decreasing because of the level spot, but you can say it's never increasing. All right, it says over the open intervals in which the function is decreasing, select the correct choice below, blah, blah, blah. The decreasing version is right here. And I'm going to highlight the decreasing. Let me erase what I need to erase. Okay, I guess we're not going to use that side. I'm going to erase these lines right here, and I'm just going to highlight the decreasing, because that's what the question said. Where is it decreasing? Right here. If you didn't, you got to read these questions. Right there. Okay? So I'm going to take my handy dandy, since decreasing is red, I'm going to highlight red. Here's my decreasing. And which way do we read? Left to right. An arrowhead means you never end up where you're at. An arrowhead means continuous. So that means parentheses. And then we go to whatever number that is, -2. So negative infinity, that's this guy right here. And positive infinity is right there. Okay? So, and something's wrong with the board on this left-hand side, so That's why it's not writing. So from negative infinity to 2, from negative infinity to 2, our function is decreasing. And negative 2 gets a solid, that's solid right there, that solid dot, so it gets a bracket. Now, a lot of people say, well, Hubert, the answer has not got a bracket in it. Why? It doesn't have a bracket because of this open circle right here. So we're going to change that to a parentheses. And then from this one to positive infinity. So from 4 to infinity, it's decreasing. So that is your answer for when it's decreasing. When is the function constant? Well, the function is constant, and you don't have parentheses because you got open circles on it. It's constant where it's level. So I'm going to take my handy dandy aqua, and here's where it is level. Now, as I tell you in the videos, there's only one thing that is in respect to y. The only thing that is in respect to y is this guy. And you need to highlight that. The range is the only thing that's in respect to y. So if they ask you the domain, the increase and decrease in value, that's all x values. The y value is the only thing that goes with the range. So all these numbers that I'm giving you, this number and this number, increasing, decreasing, that's all going to be in respect to the x-axis. X-axis and x-axis. As far as the answer. Whatever the answer is going to be in terms of x. Now, I'm going to erase all that and we're going to do the range. Range is with the y-axis. So you got to go up the y-axis. So you got to look down and go up. Okay, what's the bottom arrowhead called on the y-axis? That's negative infinity. What's the top one called? Positive infinity. So our negative arrow here is called negative infinity, positive infinity. So our function goes from negative infinity because of this guy, and then it goes, what is this? Negative 1.5 looks like. But, let's say negative 1.5, and then it picks up at negative 1, looks like. Okay, I can't see. But it looks like it picks up at negative 1. You have to blow this up a little bit. So, and I don't worry about this because this guy is solid right there, so it covers this up. So we don't have to worry about that. So our range is going from negative infinity to positive infinity. Okay? No, it's not. No, I'm sorry. I'm wrong. That's wrong. Let's do that again. Negative infinity. See, when it's so small, this area is so small, I can't see it very well. So negative infinity to negative 1.5. That's where, and then it picks up at negative 1 and goes to positive infinity. All right. So how do you write that? Well, the range is negative infinity to negative 1.5, which I think that's what you were trying to do right there. And then union means that it doesn't overlap. It picks up at the next spot. And then from 1 to what? To infinity. I think you had the right, and it does the brackets because it's closed circles. And then negative 1 to infinity. I don't mind the graph, it's just that it's so small, and this area is so small it's hard to see. So you need to blow that up so you can actually see where it's crossing. And that's how you do the domain and range. I would highly suggest that you get into the videos and watch the videos where I cover domain and range. And that's probably like the 3rd or 4th day. But I spend a lot of time on completing the square, domain, and range, so and graphing, and you'll see every day I just cover nothing but graphing, sketching the graph, domain, and range. I do about 15 different problems. So you need to check it out. You need to check those videos out, and then do the homework after you do the videos. Okay? So that takes care of the 4 questions that were sent. I'll post this on the YouTube channel as soon as I'm able to. Have a good day. Send more questions.